What is a 3D printer? A 3D printer is a machine that can reproduce three-dimensional objects from a computer-created design. It does this by a process of additive manufacturing, where material is built up layer by layer upon itself and fused together using heat or some other type of sintering. This is the opposite of subtractive manufacturing, like machining, where a part is cut from a solid piece of stock, wood, aluminum, or steel. The first affordable 3D printers were called RepRaps, and they were open source machines that you could build yourself. This open source project allowed the community to share and improve upon designs, and this rapid sharing and prototyping allowed the printers to become very good and user-friendly over time. Many 3D printer designs use 3D printed parts, meaning that you can use your 3D printer to build more 3D printers, or you can ask your friend to print parts for you. Some uses for 3D printing technology would be rapid prototyping, replacement parts that maybe you can't buy or aren't readily available, or shipping would take a long time, architectural models so your clients could see the finished product, could help promote your business in that way, making keychains with your brand on them. Educational purposes like teaching and medical training, and of course upgrading your own 3D printer. Some common materials that 3D printers use would be PLA plastic, ABS, nylon, PETG, TPU. These are all plastics. Some metals available would be stainless steel, titanium, copper. Of course, not for the average at-home 3D printer user, but there are many mail order services where you can order metal prints. And some other, I would call experimental types of 3D printing would be clay, concrete, people trying to print houses, chocolate, I've seen glass, and much more. Some common machine types would be Cartesian, Delta, robot arm mounted 3D printers. On the left is a resin printer that raises the build platform upwards out of a vat of resin as it prints the object. And no matter what the form factor of most filament 3D printers, they share a few common parts. And those parts would be the X, Y, and Z axis, frame, extruder, hot end. They're all going to need filament of some kind. They're going to have a print bed and some kind of control mechanism. This one has a touch screen. 3D printers use a Cartesian coordinate system. Moving precisely along these axes is what allows the printer to deposit plastic in a precise manner. On this particular printer, the X and Y axis are belt driven, while the Z is lead screw driven. The print bed, commonly called the bed or the build plate, is the area where the model is created. It's often heated up to help the model cool more slowly and help the part stick to the bed. It also must be leveled against the nozzle to have a consistent print quality. Filament is the material that the 3D printer uses. No matter what the material, all the different types of plastics, they're going to come in the same filament form. Different colors are available. Wood-filled filaments, metal-filled, nylon, carbon fiber. just about anything you can think of. The extruder is responsible for moving the filament through the hot end very precisely. The hot end refers to this assembly that's mounted to the x-axis here. We'll go into that in more detail in a minute, but first we'll look at the extruder. The extruder has an idler, which is a hinged part that presses the filament against the drive gear. The drive gear would be the part attached to the motor inside the extruder that drives the filament forward. The tensioner creates adjustable tension against the idler. You want it set just right so that it doesn't grind the filament, but also it drives it through consistently and reliably. And this printer has a filament sensor which will pause the print when it runs out of a filament and let you change to a new spool. The hot end here has a heater which warms the nozzle to the set temperature to melt the filament. The thermistor monitors the nozzle temperature and sends it back to the controller in a controlled loop, feedback loop, to make sure the nozzle is always at a consistent temperature. The nozzle is a precisely machined brass fitting in the end of the hot end here, and this is what allows you to put down a precise track of plastic. This printer has a cooling fan which helps the already extruded filament cool into place. Now, 3D printers create things from 3D models, but where do 3D models come from? So most 3D models were created using computer-aided design software, that's CAD software. Files can be created from scratch, or they can start with a scan. Scanning technology is becoming more readily available. It once was very expensive and hard to find. And similar to how you can search for free images online, websites like Thingiverse offer a library of free 3D printable designs that you can customize or use as they are. All the Thingiverse designs are licensed under different sharing licenses, and the site allows the user to pick the kind of license that they would like to share their intellectual property under. Tinkercad is a basic free CAD software meant for learning, and it's a great place to get started. If you can use a computer, you can use Tinkercad to start drawing in 3D. And for more advanced users, I would recommend Fusion 360. Just do a web search for Fusion 360 or the link's right there. Fusion 360 is free for personal use, but right now we're going to look at Tinkercad in a little bit more detail.